All right, let's try some practice problems now. So let's look at this first equation here, which is written in general form, but it doesn't specify to us just by the equation itself what conic section we're dealing with. Now, obviously it's a hyperbola because we're in a lesson about hyperbolas, but suppose we didn't know that. How could we determine what type of conic section we would be dealing with? Well, if you recall from our previous lessons, we would look at our A and our C values specifically. In other words, the coefficient in front of the x squared and the coefficient in front of the y squared. Now, let's look at what we have here. Our A and C values are not equal to each other. So that rules out it being a circle. Neither of them are 0, so that rules out it being a parabola. And that leaves us with either an ellipse or a hyperbola. The fact that the signs are different tells us right away that it's going to be hyperbola. So I'm going to write that here. We have different signs. This tells us we're dealing with a hyperbola. Now, I was going to do this at the end of this lesson, but might as well take care of it here. Just to remember, how can we see what type of conic section we're dealing with? When our A and C values are exactly the same, then we know it's a circle. Because when we divide out A and C, we're going to get the same value, 1 in the denominator. When A or C is equal to 0, then that means either only the x term is squared or only the y term is squared. So that's a hyperbola. Excuse me, parabola. Okay, parabola. When our A is not equal to C, then we know that we are dealing with an ellipse, and specifically we have to have the same sign. And here's an important part about hyperbola. It turns out A and C could actually be equal to each other. Okay, A and C could be equal to each other. But what is important about A and C have opposite signs. That is the critical part. So with ellipses, your denominators in your general form could both be the same, with ellipses, they had to be different values. But with hyperbolas here, if we look back at our standard form equations, it turns out a squared and b squared could be the same. Them being the same has no bearing on whether or not it's hyperbola. What matters is that they have opposite signs. So really the big thing here that I really should emphasize is the fact that A and C had different signs. That's what makes this a hyperbola. So let's try the problem now. I'm going to change my color to black. Now this part right over here is really just completing the square. So if you know how to do this, pause it and try it on your own or just follow along with me. So we've got 9 that I'm going to go ahead and factor out here. So that gives us x squared minus 2x plus some value, which I don't know what that is just yet. We'll do that in a second. Minus 4, factor that out. We've got y squared plus, be careful with your signs here. This is probably the number one place I see students mess up. 6y plus some other value. And we've got the constant, which I'm just going to add to the other side and leave some space for the values that we're going to add. So let's complete the square. So inside the first polynomial, we're going to go ahead and add 1. That means we're actually adding 9 to this side. And in the second polynomial, I'm going to add 9, which actually means we're subtracting 36 from both sides. So we've got to be really careful with those signs there. And let's clean that up. We've got 9 x minus 1 squared minus 4y plus 3 squared is equal to, do some quick arithmetic, that should be 36. And divide everything by that value of 36 because we want that right side to be equal to 1. So we've got 1, and that means x minus 1 squared, 4 minus y plus 3 squared over 9. And just quickly check my math, and I think that's it. So we have here our standard form equation. Whoa. Okay. All right, so now that we have our standard form equation, let's actually analyze this. We first want to look at which of our terms is going to be positive. Let me just change color here to be our kind of notating color. We notice that our x term is positive. I'll write that. X is positive. So the fact that our x term is positive tells us that our transverse axis is going to be horizontal. right? And ask yourself, what does that mean about which way my branches are going to be opening? If my transverse axis is horizontal, my branches are opening left and right. And then that tells me that this has to now be my a squared term, and 9 here has to be my b squared term. So if a squared and b squared are known, that means we can write a is then 2, b is the square root of 9, which is 3. And while we're at it, let's find our f value. We know that a squared, 2 squared, plus 3 squared is equal to f squared. F squared then has got to be equal to 13. That means f is just equal to root 13. We don't have to worry about plus or minus because f is a distance. Now, just to finish this off, let's go ahead and find where our center, our vertex, and our foci are. So first off, our center. Where is our center? Well, again, we just look at our h and k values. So looking at our equation, our h is 1. Again, that's just our 1. Our k is just right here. It's going to be negative 3. And let's actually go ahead and graph this as we go along. So 1, negative 3, that's where our center is. Now, because our transverse axis is horizontal, and we know our a value is the distance from our center to the vertex, I can now draw my vertices on each side of my center and write that as being negative 1, negative 3, and positive 3, negative 3. There are vertices. Again, keeping in mind that our transverse axis is horizontal, we're going to keep on going now to find our foci. Now, each focus is going to be root 13 units on each side of our center. It's root 13 units away from the center. Well, square root of 13, I don't know exactly what that is, but I do know that the square root of 9 is 3, so that means it's got to be 3 point something. So I can just roughly graph that somewhere around here. It doesn't have to be totally precise right now. So count 3 and some change units on either side, and there's our focus on that side. So there are all the points that lie on our transverse axis. And for us to identify where our two foci are, we're going to say it's going to be 1, which was the x value of our center, plus root 13. And that's actually the most precise way to write that because root 13 is an irrational number. Negative 3, that gives us this particular focus on the right side. And if we just subtract root 13 units away from 1, so let's just go ahead and concisely write that as 1 plus or minus root 13, negative 3. There's our other focus coordinate. Now, to accurately graph a hyperbola, we need our asymptotes. So again, let's think about what our asymptotes look like here. Since we know that this is our a value here, our distance from our center to our vertex is our a value. That means our b value is going to go in the perpendicular direction, and we know b is 3. So if we count up 3 units, there's our b value. Let me actually just write b instead of 3. B value is 3. So our asymptote is going to have a slope of 3 over 2, or plus or minus b over a. So I'm really just going to count our slope units out. So up 3 over 2. Up 3 over 2, up 3 over 2. Let's go the opposite direction. Down 3, back 2, down 3. Well, I think that's enough points to graph our asymptote. So there is our first asymptote. And let's clear out our b over a just so we don't get too clogged up here. Now let's go the opposite direction. We're going to go up 3, back 2, up 3, back 2. And from the center, let's go the other way. And if we plot all these points, there's our second asymptote. Well, from here, all we need to do to graph our branches is we start at one vertex. So here's our first vertex. And all I'm going to do is I'm just going to hug this asymptote. Don't worry about plugging in any additional points. We don't need to. We're just going to go ahead and hug that asymptote the best as we can. Just make sure we're getting closer and closer to that asymptote in either direction. right? And that's a pretty decent looking hyperbola. Not great, but pretty decent looking. We can use that. The one thing that I really just want to caution you on is just drawing just terrible hyperbola branches. Just something like, I've seen students do stuff like this. And that really doesn't make any sense because now you've got branches going away from your asymptotes, which again, it doesn't make any sense to do that. So I'm going to erase that because it makes my eyes hurt. And there you go. We got the first problem done. Now let's try the next two problems. Oh, I forgot to mention, sorry. I never gave you the equation for these asymptotes here. So let's go ahead and write those equations. Y minus k, and our k is just the k value from our center. So y minus -3, so I'm just going to write y plus 3, is equal to plus or minus, and ask yourself, we've got plus or minus 3 over 2, x minus 1. There's our asymptote equations. And I am also noticing that the directions ask for the eccentricity. Eccentricity is just equal to f over a, which in this case is going to be root 13 over 2, right? Okay, now let's try these problems below. We can finally get to them. So in these two problems, I'm actually giving you information about the hyperbola, but not actually giving you the graphs themselves or the equations. So if you recall what I suggested you do with problems like this in previous lessons, I said, draw a picture. This is not mandatory. You don't have to. I would never grade your picture, but this is just really to help ourselves see how everything is situated. So if we got one vertex at 3, 0, and another vertex at 3, 4, we got this one vertex, that already is huge because this already tells us that our transverse axis is going to be vertical, which that means right away I can start writing out my standard form equation. I know my y term is going to be positive and my x term is negative. And I know my right side is always equal to 1 for a hyperbola. So just those 2 points already give me that much information. And while I'm at it, might as well figure out where my center is. Well, I know my center is going to be exactly halfway in between my two vertices. Well, halfway between 0 and 4 is going to be 2. So my center coordinate is going to be 3, 2. So that means I can write those points there and fill that in. And even with that bit of information, I also know that the distance from my center to my vertex is 2, which means this is my A value. The A value is the distance from the center to the vertex. So that means since A is equal to 2, I can write that this is going to be equal to 4 there. So just with 2 vertices, we got all that information. All we're missing now is our B value. Well, that's where this next part comes in, looking at the asymptotes. So if we know that our A value is equal to 2, and our slope here is written as 2 over 3, let's write that out. If we know that our slope is 2 over 3, and our A value is 2, that means our B value here has to be equal to 3. So from that, we can establish B is equal to 3, and just from that, we can write we've got 9, B squared. Okay, so now I suggest that you pause the video, try the second problem on your own, see if you can give that a go. So let's do the second problem. So we've got me drawing a picture here, and I'm just going to go ahead and plot those points. So first off, I've got 0, 0 is one focus, 8, 0 is my second focus, and my two vertices. I've got one vertex at 3, 0, and my other vertex at 5, 0, and that's actually not that great, but whatever. Again, I don't really care too much about this, all that I'm just plotting these points. So I've got these points here. So hopefully you've had an opportunity to think about what this means. If I've got two vertices there, first off, I know that my axis is going to be horizontal. So in this case, my x term is positive. Okay, so I'll just pause and stop there. I just know my x term is positive, which means my y term is going to be negative. The next thing I know is where my center is. I know that my center is exactly halfway in between the two vertices or halfway between the two foci. So that's where that is. I can go ahead and start filling in what we know. My x term component is 4. My y component then is 0. So that means for my y component, I can just write this, y squared. I don't need to write y minus 0 squared. I know that my branches are going to be opening left and right. Just roughly sketching this so I can visualize it. And I know that the distance from my center to my vertex, this a value, is equal to 1. Well, that's going to go underneath my x term, so a is equal to 1, so 1 squared is just 1. And I know that my distance from my center to my focus is equal to 4. Well, let's just make some space for this. Well, think about this. F squared is equal to a squared plus b squared. If I know f is equal to 4, so that's 16 is equal to 1 plus b squared is going to be equal to 15. And that's all I need to do to write over there. There's my b squared. There's my a squared. I've got 1. And this here is my standard form equation. Might as well box my previous one here. Okay, so anytime you have these problems where you're given information but don't have the equation, draw a picture and you can get a lot just by looking at how everything is situated.